If we wanted to achieve the octagon length, plate lengths, mathematically, the number of sides or the lengths of sides mathematically, I would use one of these trigonometry calculators. It's so unpopular nowadays, it turns out. And it's really simple though. It's actually, I've been told that's a few more keystrokes, you know, which is where you're talking about minutes. If you learn production cutting, you could save hours and days, you know. I could cut probably 4 times the speed of, and cut off 3 carpenters a roof with production methodology. And so I don't worry about keystrokes so much. Most of all, I don't want to be once removed. I want to know what it is that I'm doing. So anyway, there's a table that they just put into this. It's essentially, they just put it in, and it's the ratio of degrees, angles essentially, to lengths of 1. So for example, if you had 12 inches on the level and 6 inches of rise, that would be 0.5 of 12. The rise would be 0.5 of 12, and 0.5, there's a corresponding tangent to 0.5. 26.5, I think is a 612, yeah, 26.5. So in here, when you punch 26.5 and then you push tangent, it says 0.5. 26.5 tangent is 0.498, 0.5. So anyway, that's how it works. In an octagon, the way you figure it out mathematically. Now, the other thing that scares carpenters away is the fact that it's in decimals. And they're operating in eighths, so they have to go from tenths to eighths, and they think, oh, that's going to be hard to remember. But actually, you guys already know how to do it. You do it all day long with money. You know, a quarter is 25 cents, 0.25. You know, 50 cents, you know, 75 cents, 0.75. There used to be, Americans are obsessed with eighths and always have been. So there used to be a coin called a bit, which was 12.5 cents, and it was half a quarter, and that's an eighth. It's an eighth of a dollar. It's also an eighth of a tenth, 0.125. Instead of 12.5, just move the decimal, 0.125. If you added 12.5 cents to a quarter, it would be 37.5 cents, 0.375, would be 3/8, right? Because we're dealing with eighths. If you take that eighth of a dollar, 12.5 cents, and you add it to 50 cents, that's 67.5 cents, or move the decimal, 0.675 is 5/8, and you keep doing that. 3/4 plus 12.5 cents, 75 cents plus 12.5 cents is 87.5 cents, or 0.875. You now all of a sudden you know the conversion from eighths of an inch to decimals. It takes about 12 minutes if you focus your attention. Believe me, a lot easier than moving beams and so on. So anyway, point being is that I would want to figure out what the lengths of the sides are mathematically for a 36-inch wide octagon. And the way you would do that, you would take 360 degrees and you would divide it by twice the number of the sides, because just like I said before, we need to have the common rafter run. So that would mean instead of dividing it by 8, we divide it by 16, and that would give us half the plates, you know, common rafter to hip rafter, triangle, right triangle. So we divide by 16, and that would give us 22.5. So we could do that. We go 365 divided by 16, that would be 22.5, and then we push tangent, which is basically a chart that they just put in the calculator, and that would give us the ratio of the side of a 22.5 degree angle to the run of it. And it is what is it? Yeah, 22.5 tangent is 5 inches, 4.14. Not 5 inches, 4.14. 22.5 tangent, 4.14. And then we multiply it by the width of this building, in this case 36 inches, times 36 inches equals 14.91. And then instead of taking this 36-inch square and dividing it diagonally, you divide it square to the sides, have the same center line mark, and then you would take half of 14.9 on either side of the line on all sides, and that would give you the plate line, 14.9. So from center line, half of it and half of it, 14.9. and then you would connect dots. That would give you the octagon mathematically. Very simple. Not any more keystrokes, I can't imagine.